Hello everyone, welcome back to my tutorial. In this tutorial, we are going to solve 1/4 of the ring in code aster. We'll solve this case. So this is material of steel. The Young's modulus of 210 gigapascal and Poisson ratio is 0.3. Here I have showed the boundary conditions. This surface is we are going to fix it. Here we are going to apply a compressive load or pressure of 20 megapascal. So this is our case. This case I have taken from the pre-promax tutorial. So pressure loaded ring segment. So this is the case I have taken. Now we will solve this case and we will compare the result with analytical result. So first we'll open salome meca. I have kept salome meca here. Salome meca is the free and open source finite element solver, and it has code aster is the free and open source finite element solver, and salome meca is for pre-processing and post-processing. Now go to geometry. So now we'll create our geometry here. So geometry is outer diameter is 150 mm and inner diameter is 90 mm. Here they have specified. Just go here. First you convert this diameter into radius. First diameter is, you just convert into meter first. So divided by 1000, so 0.15. First inner diameter is 0.09. Small d, and thickness is 0.02. Okay, so first we'll go to salome meca. First we'll create a cylinder, or we'll go to new entity, basic. We'll create a circle, center OZ. Now we'll create an OZ. So first it asks radius. First we'll specify the outer radius. Outer radius is 0.15 divided by 2. Just go to calculator. So 0.15 divided by 2. 0.075. 0.075. Just apply. Now we want to create one more circle. Just go to the, so inner diameter is 0.09. So by half of the value radius, we'll divide this value by 2. 0.09 divided by 2, 0.045 will come. So now just specify 0.045 is the radius. Just apply. Now just go to fit screen. Now we can see the two circles here. Close. Now we'll build the face to the circle. Select both the circle. Build face. Now it has generated a circle in between the two. Now we'll save this file. Go to file, just save it. Now I have saved it, and it has a thickness they have mentioned. Select this face, go to operation. So go to new entity. There is an option called generation. Here you can see extrusion. So select this face. Base is the face. Vector is Z, normal to that. And we need to specify the height. Height is nothing but thickness here. So just go to the PPT. The thickness is 0.02. 0.02. So this is the ring. Just apply and close. Now we have created this ring. In our case, we need to take only the quarter. We need to divide this ring. So for that, we'll go for partition. Just go to basic, new entity. We'll create a plane, then we'll partition it. Select this, enter origin, X, give the size of 1, or we can give 0.5. Any size we can create a plane. So 0.5 is enough. Just apply. Again, just go to select O, this one, and apply and close. Now we have created 2 planes. We'll divide this geometry using these 2 planes. Go to operation, partition. So base object is the extrusion, tool object is the 2 planes. Just press the Ctrl and hold, select these 2 planes. Now we'll get 2 objects here. Just apply and close. Now just see, we can see the edges, nothing but we have created the surface here in between. So now we'll select this partition, go here, explode, solid, select the surface, only one we can explode it, this volume we want it, apply and close. Just see, now we want only this object. We'll keep this object. Now we'll create a groups to apply the boundary conditions. So this is our model. Now just right click here, create group, face group. Here the bottom surface I just want to fix it. Select this face, add. This one is fix. Just apply. Now just select this space, add. Here we need to apply a pressure. Apply and close. Now we have created the model and we have created the groups. Now we'll save this file. Now we'll move into meshing model. Mesh. Now we are in mesh model. Select the solid one. This is my object. Just go to mesh, create mesh. Now we can choose hexa element also. For example, we want to go for hexahedron, 2D, quadrangle mapping, 1D, wire discretization, local length. We'll give this coarse mesh, say OK, apply and close. Right click this mesh one, compute. So it has generated very coarse mesh. If you want to make finer, we can go for fine. Right click, edit mesh. Here you specify 0.005. Just OK, apply and close, compute. So here it has 2 edges, that's why it's not generating. Right click, edit mesh. Here we have 2 edges, that's why we need to control every edge. Instead we can directly go for it takes time for meshing. Instead of focusing meshing, I will show how to solve it. And meshing tutorials, I will explain how to create X mesh for this kind of geometry. Okay, now we'll move into tut mesh. .005. Save OK and apply and close. Right click, clear and compute. Now we have created the tut mesh. What is the size they have mentioned in their model is 3 mm. I have given 5 mm. So we'll reduce this into 3 mm. Compute. So this is the mesh generated. Now we are done of creating mesh, and you see the groups also we have taken into the mesh. Now we'll move into aster study to create the setup. Just go to aster study. Just say OK. Now we can use assistant, isotropic linear elastic assistant to wizard to create the setup. So here we can go to next. This is the mesh. Our case is 3D. So we need to specify the material property here. So 210 gigapascal and 0.3, just leave it. and we need to fix group here 0 and 0 and 0, and go to next. Here we need to apply the pressure of 20 megapascal. Everything we are specifying in e power 6. Mega means 10 power 6. Next, we need to specify the location and file name. So this name is capital result1.rmed. So this is the file name I am giving. Say OK. Just finish it. Now I have created the full setup. We need not to change anything. The only thing is it will calculate only the primary variable of displacement. If you want to see one meter stresses and directional stresses, we need to calculate from the displacement to stress values. For that, just go to post processing. There is an option for calc champ. So use the same name, result. Here there is an option for constraint. Here we can choose sigma is nothing but directional stresses. Deformation means strain, everything we can take. Criteria, from that we can take equivalent stresses. SIEQ means equivalent stress in element and node. Similarly, we can find the reaction force also. Force nodal and reaction nodal we can calculate. This is, we can switch it on. Just apply, say OK. Now we have created. Now we need to save the results. So we need to edit output results also. Just go here, edit. Instead of results data meca static, we need to choose calc champ. Choose on miss. There is an option called tout champ. Just tick it. Just make it S. Just OK. Just apply. Say OK. Now we have created complete setup to solve this steady state, static analysis of this ring. Just save it. Now we can run this case. I'm just making this auto refresh into 5 seconds. We can change this everything. This will not take much time, so I'm just keeping everything. 15 minutes is the maximum. Just run it. Now we'll see the PreProMax tutorial. So after applying this, the stress value at the similar outer shorter edge of the fixed face. Here they are saying that the stresses we are getting here is 230.68 megapascal. Now see, our case is solved without any error. Now we will see the results using paraview. Go to post processing, paraviews. Right click, open. This is our result file. Just open it. Just apply it. Now we have, here you can see there are different values we have calculated. While solving any solver, it will calculate the primary variable. For static, it solved the displacement. From that we need to derive the other values. So now displacement, just go here. So this is the displacement value. We are applying compressive load. Now we can go for stress also. Equivalent stress, von Mises stress. So we are getting 240. Here you can see we are getting 240 megapascal. That means 2.4 e power 8. So that is the value we are getting here. If you want to check the results, so just go to your point. Place this point here. Otherwise, just go to selection display inspector. Just go to view, windows. There is an option called selection display inspector. Switch it on. It will come the dialog window here. Here you can see this is the selection display inspector. Choose the equivalent. Now we can select the node where you want to see. So I have selected this node. So there are different value it shows. It's coming around 219 megapascal. So this is the van Mie's stress value. From the one by one the value it's showing every value. This is the first value is the van Mie's stress. So now we'll compare the result with the pre-pro max. It's coming around 230. Now here we are getting 220. Around 10 megapascal it's varying. And we can check the maximum value where it's getting. Around here we are getting. Here we are not getting maximum value. Here only we are getting maximum value. We can compare the results here also. But maximum we are getting 240 megapascal. Here we are getting 220 megapascal. So this is the way we can check the results. So now we just untick this value. So to take the color pictures, there are different color pictures format we can use. So I will show you how to set it. So this is the way we can go for. I'm just used to choose blue to red rainbow, apply and close. Here there is one more option here. The label also we can set it into 12. So this is the value. This is the way the result will show. If you want to animate the values, just go for wrap vector, make it some scale factor, just apply it. So this is the way it will get pinned. Now we just select this play button, create a new animation track, just say OK. Now we can animate it. To make it loop, so this is the way we can see the results. Thank you for watching my videos. Please subscribe my channel for more videos. Thank you.